Greetings everyone. Welcome to another episode of Junior School Mathematics. Our topic for today's class is prime factorization of numbers. First thing we need to know is prime factor. Prime factor is a combination of two words, prime and factor. What is prime? A prime number is a number which has exactly two factors, 1 and itself. This means any number that can only be divided by 1 and itself is called prime number. Example, 2. 2 is a prime number because it can only be divided by 1 and itself. 3. 3 is a prime number. It can only be divided by 1 and itself. But 4. 1 and 4. Aside 1 and 4, there is still another number that can divide 4, and that is 2. This makes 4 not to be a prime number. A factor. A factor of a given number is a number that divides the given number exactly with no remainder. As we have it here, 1 will divide 4 without any remainder. 4 will divide 4 without any remainder, and 2 will divide 4 without any remainder. That means that the factors of 4 are 1, 2, 4. But 3 is not a factor of 4 because 3 cannot divide 4 without any remainder. Prime factor. Prime factor of a number is a prime number that divides the number with no remainder. The prime factor of 4 is 2. How? We have the factors of 4 to be 1, 2, 4. Is 1 a prime number? No. Is 2 a prime number? Yes. Is 4 a prime number? No. The only prime number we have here is 2. That means the prime factors of 4 is 2. We then move on to prime factorization. Prime factorization of a number is writing the number as a product of its prime factors. Examples, 12 can be written as 2 times 2 times 3. 30, 2 times 3 times 2. How to find prime factors of a number? To find prime factors of a number, we follow these steps. Example 1. First step, split the number up into a pair of factors. Think of two numbers that if you multiply them together, you will have 12 as your result. Example, 4 times 3, 2 times 6. 4 times 3, 2 times 6. You may decide to use 4 times 3 or 2 times 6. Step 2. Then split each of those factors up into another pair. Can we have two numbers that if we multiply them together, we will get 4? That is 2 times 2. We are going to split these 2 into 2 times 2. Do we have any two? Can we have two numbers that if we multiply them together, we have 3? That is only 1 and 3. That means 3 is a prime number. We don't have to split this. 2 is a prime number. We don't have to split this. 6. Do we have any two numbers that if we multiply them together, we have 6? That is 2 and 3. Step 3. Continue splitting up factors until you get a prime number. This is a prime number. This is a prime number. That means we are not going to split them again. This is a prime number. This is also a prime number. That means we are not going to split them again. So if we are using this, the prime factors of 12 is 2 times 2 times 3. And the factorization of 12 here is also, we start with this, 2 times 2 times 3. Let's just go with 1. 4 times 3. 3 is a prime number. That means we are not going to split this. 4 is not a prime number. Two numbers that we multiply together that will give us 4. That is 2, 2. 3 is a prime number. 2 is also a prime number. 2 is a prime number. That means that the factorization of 12 is 2 times 2 times 3. Next example, we have 36. Two numbers that will multiply together that will give us 36. 6 times 6. 6 times 6. 6 is not a prime number. 6 is not a prime number. That means we are going to split them. Two numbers that will multiply that will give us 6. 2 times 3. Is 2 a prime number? Yes. Anytime you have a prime number, circle it. Is 3 a prime number? Yes. Is 2 a prime number? Yes. Is 3 a prime number? Yes. That means we are not going to split further. We have this to be 2 times 3 times 2 times 3. 2 times 3 times 2 times 3. But let's arrange them in order. 36 is equals to, how many 2 do we have here? That is 2, 2. 2 times 2 times 3 times 3. The next example, 54. Think of two numbers that if you multiply them together, we are going to get 54. In our last class, we discussed the test of divisibility. Can this number be divided by 2? Yes, because the last digit here is 4. That means 2 times 54 divided by 2, that will give us 27. Is 2 a prime number? Yes. 27 is not a prime number. 27. What two numbers are you going to multiply together that will give us 27? 3 times 9. Is 3 a prime number? Yes. Is 9 a prime number? No. That means we will expand this again. The two numbers that we are going to multiply together that will give us 9 is what? 3 times 3. Is 3 a prime number? Is 3 a prime number? That means that 54 is 2 times 3 times 3 times 3. Next example, 112. Think of two numbers that if we multiply them together, we will get 112. Let's start from 2. Can 2 divide 112? Yes, because the unit digit is what? Is 2. Now, 112 divided by 2, what are we going to get? That is 2 multiplied by 56. 2 is a prime number, but 56 is not a prime number. Expand this again. Start again from 2. Is this divisible by 2? The unit digit here is 6. That means it is divisible by 2. 56 divided by 2, we have 2 times 28. 2 is a prime number. 28 is not a prime number. Is 28 divisible by 2? Yes. The unit digit is what? Is 8. 28 divided by 2, that is 14. We have 2 times 14. 2 is a prime number. Two numbers that will multiply together that will give us 14 is what? 2 times 7. Is 2 a prime number? Yes. Is 7 a prime number? Yes. This means that 112 is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 7. Next example is 144. Think of two numbers. We can also start by using test of divisibility starting from 2. Because the unit digit here is 4, that means it is divisible by 2. And I can also use 12 times 12 as the pair. I will have this to be 12 times 12. Is 12 a prime number? No. That means I will expand this. Is 12 a prime number? No. Two numbers that will give me that their product is 12 is what? 3 times 4. 3 times 4. Is 3 a prime number? Yes. Is 3 a prime number? Yes. Is 4 a prime number? No. Is 4 a prime number? No. Two numbers that their product will give us what? 4. That is 2, 2, 2, 2. Now 144 is equals to 3 times 2 times 2 times 3 times 2 times 2. How many 2 do we have here? That is 4. This is equals to 2 times 2 times 2 times 2 times how many 3? 2, 3 times 3. The next example, 300. 300. Anytime we have a bigger number like this, let's make use of our divisibility test. The unit digit here is what? 0. That means 300 is divisible by 10. 30 times 10. Also, the unit digit here is 0. 30 is divisible by 10. 3 times 10. Is 3 a prime number? Yes. Is 10 a prime number? No. The two numbers that we multiply to get 10 is what? 2 and 5. Is 2 a prime number? Yes. Is 5 a prime number? Yes. These two will give us 2 and 5. So we have 300. 3 times 2 times 5 times 2 times 5. We have 2 times 2 times 3 times 5 times 5. I can still write this in index form. The prime factors that we have here are what? 2, 3, and 5. 2, 3, 5. To write this in index form, prime factor that we have is 2. How many 2? That is 2. 1, 2. Times 3. How many 3? 1. Times 5. How many 5? 2. 2 raised to the power of 2 times 3 times 5 raised to the power of 2. This is the index form. This is also a bigger number. The unit digit here is 6. That means it is divisible by 2. 2 times 546 divided by 2. We have 273. Is 2 a prime number? Yes. 273 is not a prime number. This is also a bigger number. 273 cannot be divided by 2 because the last digit is odd number. Let's test for 3. The divisibility test of 3 is what? Sum of the digits must be divisible by 3. And this is 12. Can 3 divide 12? Yes. That means that 273 is divisible by 3. 273 divided by 3, we have 91. 91. Is this divisible by 3? No. 9 plus 1 will give us 10. 10 is not divisible by 3. 4. No. 5. The unit digit must be 0 or 5. But we have 1 here. No. 6. It must be divisible by 2 and 3. But 91 is not divisible by 2. That means it's not divisible by 6. 7. Is 91 divisible by 7? What is the divisibility test of 7? We have 91. To know if 91 is divisible by 7, that is 9 minus twice the unit digit, that is what? 2. This is equals to 7. Is 7 divisible by 7? Yes. That means this is divisible by 7. 91 divided by 7, we will have 13. Is 7 a prime number? Yes. Is 13 a prime number? Yes. That means that 546 is 2 times 3 times 7 times 13. This is also in index form because we don't have more than 1 2, 1 3, 1 7, and 1 13. The next is 576. This is also a bigger number. 576. The unit digit is what? 6. That means it is divisible by 2. 2 multiplied by 576 divided by 2, that is 288. The unit digit here is also what? Is even number. That means that it is divisible by 2. 288 divided by 2, that is 144. I can have this to be 12 times 12. This is not a prime number. Reduce it. This is 4 times 3. And also this is 4 times 3. 4 is not a prime number. We have this to be 2, 2. Also here, 2, 2. The prime numbers that we have here is what? 1, 2, 3, 4, 5, 6, 7, 8. 576 is equals to 2 times 2 times 3 times 2 times 2 times 3 times 2 times 2. The prime factors that we have is what? 2 and 3. How many 2? 1, 2, 3, 4, 5, 6. Times how many 3? 1, 2. This is the index form of 576. Next is 1440. The unit digit here is 0. That means we will first of all divide this by 10. And we have 144 multiplied by 10. 144 is the same thing as 12 times 12. And the prime of this is 2 and 5. 5 is a prime, 2 is a prime. We can divide this further to be 4, 3. 4, 3. 3 is a prime, 3 is a prime. This can be the 2, 2. 2 is a prime, 2 is a prime, 2, 2. 2 is a prime, 2 is a prime. That means 1440 is equals to 2 times 5 times 3 times 3 times 2 times 2 times 2 times 2. And we have this to be, how many prime factors do we have? 2, 3, 5. First of all, write 2. How many 2? 1, 2, 3, 4, 5 times 3. How many 3? 1, 2. Oh, sorry, it's 2. And just single 5. So what will be the prime factorization of these three numbers in index form? Next is to discuss the number of factors of a number using prime factorization. Number of factors of a given number. What do we mean by this? Let's assume we have 12. What are the factors of 12? 1 is a general divisor. 2 divides 12. 3 divides 12. 4, 6, and 12 itself. How many factors do we have here? 1, 2, 3, 4, 5, 6. This means that the number of factors of 12 is 6. What if we are given a bigger number like 1000? Are we going to use this same approach? No. Let a number n be expressed in index form, the prime factorization of the number. We have 12. Let's write 12 as the product of its prime. 4 times 3. 3 is what? 3 is prime. But 4 is not a prime, right? This is 2 times 2. 2 is prime. 2 is prime. That means that 12 is equals to 2 times 2 times 3, which is equals to 2 raised to the power of 2 times 3. How many 3? 1. Then the number of factors of 12 is given as A1 prime. The first one, A1 is for the first prime number that is here. What do we have here? The A1 is 2 plus 1. A2 plus 1. A2 here is 1 plus 1. And this is equals to 2 plus 1, 3. 1 plus 1, 2. 3 times 2, that is 6. That means that the number of factors of 12 is 6, which is the same as what we got earlier. Steps. The first step is write the given number as product of its prime factor. Second, apply the formula. Examples. Let's write 12 as the product of its prime factors. 4 times 3. 3 is what? Prime. This is not a prime. 2, 2. 2 is prime. 2 is prime. This means that we will have 2 times 2 times 3. Let's write this in index form. The prime factors that we have here is what? 2 and 3. How many 2? 1, 2. Times 3. How many 3? 1. So that means that 12 is equals to 2 raised to the power of 2 times 3 raised to the power of 1. Number of factors is equals to, apply the formula A1, the first power here, that is 2 plus 1, open another bracket, 1 plus 1, this is equals to 3, 2. 3 times 2, that is 6. Second example, 20. Let's write the prime factorization of 20. 4 times 5. 5 is prime, but 4 is not prime. This is 2, 2. 2 is prime, 2 is also prime. That means we will have this to be 2 times 2 times 5. 20 is equals to 2 times 2 times 5. In index form, the prime factors that we have here is what? 2 and 5. 2. How many 2? 1, 2. 5. How many 1? 5. 1. Number of factors is equals to, is 2, add 1 to it, open bracket, 1, add 1 to it. This is equals to 3 times 2. This is equals to 6. This means the number of factors of 20 is what? Is 6. 3. 36. 36 is 6 times 6. 6 is not prime. That means we will find two numbers that their product will give us 6. This is 2 and 3. 2 is prime, 3 is prime. Also we have 2 and 3. 2 is prime, 3 is prime. This is equals to 2 times 3 times 2 times 3. Rearrange. 2 times 2 times 3 times 3. In index form, how many 2? That is 2. Times 3. How many 3? That is 2. What will be the number of factors of 36? The power we have here is what? 2. Add 1 to it. 2 plus 1. Another bracket. The power we have here is what? 2. 2 plus 1. And this is equals to 3, 3. 3 times 3, that is 9. That means that the number of factors of 36 is 9. 4. 100. The last digit here is what? 0. That means 100 is divisible by 10. We have 10 times 10. 10 is not what? It's not a prime number. This will be 2, 5, 2, 5. 2 is prime, 5 is prime, 2 is prime, 5 is prime. This is equals to 2 times 5 times 2 times 5. Rearrange. 2 times 2 times 5 times 5. In index form, 2 raised to the power of 2 times 5 raised to the power of 5. Now, what will be the number of factors? 2 plus 1, the power here again, 2 plus 1, 3 times 3, and that is equals to 9. Next, we have 136. We have 136. Let's use divisibility test. The last digit here is what? Is 6. That means this number is divisible by 2. 2 times 136 divided by 2. That will give us what? 68. 68 is also divisible by 2 because the unit digit is what? Is 8. This is a prime. 2. 68 divided by 2. 34. This is a prime. 34 is also divisible by 2. The unit digit is what? Is 4. 34 divided by 2. That is 17. Is 17 a prime? Yes, 17 is a prime. That means we have 2 times 2 times 2 times 17. In index form, 2 raised to the power of 3 times 17 raised to the power of 1. What will be the number of factors? The power here is what? 3 plus 1. The power here is what? 1 plus 1. And that is 4 times 2, which is equals to 8. The number of factors of 136 is 8. Next example. 1440. The last digit here is what? 0. That means this number is divisible by 10. 144 times 10. 144 can be written as 12 times 12. Also, 10 to 5. 5 is a prime. 2 is a prime. 12 is not a prime. That means we will have this to be 4 times 3. 3 is a prime. 4 is not a prime. 2 times 2. Same thing applicable to this 12. 4, 3. 3 is a prime. 1440 is equal to 2 times 5 times 3 times 3 times 2 times 2 times 2 times 2. The prime factors that we have here is what? 2, 3, 5. This is equals to 2. How many 2? 1, 2, 3, 4, 5 times 3. How many 3s do we have? 1, 2, 5 raised to the power of 1. What will be the number of factors of 1440? The power here is what? 5. Add 1 to it. Power here is 2. Add 1 to it. And the power here is what? 1. Add 1 to it. This is equals to 6 multiplied by 3 multiplied by 2. 3 times 2, 6 times 6, 36. That means the number of factors of 1440 is 36. Next example. 1000. Oh, 54. This is even number. It is divisible by 2. So we have 2 multiplied by 54 divided by 2. That is 27. This is prime number. 27 is also 3 times 9. This is also prime number. But 9 is not a prime number. 9 is 3 times 3. Prime number. Prime number. So we have 54 to be 2 times 3 times 3 times 3. In index form, 2. How many 2? 1 times how many 3? That is 3. Number of factors is, the power here is what? 1. Add 1 to it. Multiply by, the power here is what? 3. Add 1 to it. That is 2 times 4, which is equals to 8. Next on the list is 1000. We have 1000. This is divisible by 10 because the unit digit is what? Is 0. This is also divisible by 10. The unit digit is 0. Now we have this to be 2, 5. 2 is prime, 5 is prime. 2 is prime, 5 is prime. 2 is prime, 5 is prime. So that means 1000 is equals to 2 times 5 times 2 times 5 times 2 times 5. This is equals to, let's rearrange. 2 times 2 times 2 times 5 times 5 times 5. In index form, how many 2 do we have here? 3. How many 5? 3. Now, the number of factors is, the power here is what? 3. Add 1. The power here is what? 3. Add 1. 4 times 4. And that is what? 16. The number of factors of 1000 is 16. Next is, this is also a bigger number. This number is divisible by 2 because the unit digit is 6. 2 is prime. 546 divided by 2, that is 273. 273 is not divisible by 2 because the unit digit is odd number. Let's test for 3. 273 will be divisible by 3 if the sum of its digits is divisible by 3. 2 plus 7 plus 3, this is 12. Can 3 divide 12? Yes, that means 3 will divide 273. We have 3. 273 divided by 3, that is 91. 3 is odd. 91. 2 cannot divide 91. 3 cannot divide 91 because 9 plus 1 is 10. 3 cannot divide 10. 4 cannot divide 91. 5 cannot divide 91. 6 cannot divide 91. 7. Let's test for 7. The divisibility test of 7 is 9 minus twice the unit digit. 2 times 1, that is 2. 7. Can 7 divide 7? Yes, 7 can divide 7. That means that 7 will divide 91. 7 is odd. 91 divided by 7, that is 13. That implies 543 is equals to 2 times 3 times 7 times 13. This is already in index form. 2 raised to power 1 times 3 raised to power 1 times 7 raised to power 1 times 13 raised to the power of 1. What will be the number of factors of 546? Power here is what? 1. Add 1 to it. Power here is what? 1. Add 1 to it. Power here is what? 1. Add 1 to it. Add 1 to this too. So this is 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. That is 16. This means that number of factors of 546 is 16. With this explanation, what is the number of factors of these numbers? This is the end of today's class. Thanks for watching. Don't forget to like, share, and subscribe. See you in the next class.